Good morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today I am going to discuss a topic called lightning protection from a subject Industrial Electrical Systems. These are the different contents which I am going to discuss today, like what is lightning, what are its facts, and different lightning protection systems, what are the different types of elements which are being used, and how to choose the conductors for the protection device. What is lightning? Lightning is a tiny ice particle. It is a tiny ice particle in a cloud. Which collide with each other. They built up a positive electric charge. That means inside the cloud, the ice particles will collide with each other. Due to this collision, they provide a positive electrical charge. And when the potential difference between the ground and the cloud is more, the breakdown of voltage in the air occurs. That means this is the cloud and this is the ground. If at all a potential difference occurs, potential difference between the ground and the cloud is more than the breakdown voltage. That means if the potential difference is more than the breakdown voltage in the air, the lightning strikes the ground. The lightning directly strikes the ground. So this is the lightning. And what are the facts of a lightning? That is, lightning heats up the surrounding air to about 20,000 degrees centigrade. 20,000 degrees centigrade, and can hit with 500 kilovolts of voltage. That means the lightning voltage is around 500 kilovolts. 500 into 10 power 3 volts, and more than 10,000 amperes. The current is around 10,000 amperes and the voltage is around 500 kilovolts with a temperature of 20,000 degrees centigrade. And around these many people can struck by lightning each year, and almost 24,000 are being killed because of this lightning effect. Lightning protection. The lightning protection system, LPS, you will call it as LPS. It is mainly designed to protect the structure or building. If at all any tall building is there, in order to protect the building and in order to protect it from the damage, the intensely high voltage currents from the different that is, as I said, the voltage is around 500 kilovolts and current is around 10,000 amperes. In order to protect the building from this amount of voltage as well as current, we will have to design different type of lightning protection schemes. The different types of lightning protection systems. LPS, lightning protection system. There are different types, that is conventional as well as non-conventional. In conventional, the first one you will call it as Franklin rod, and in second one you will be using Faraday's cage. In non-conventional, we will be using the CTS as well as DAS. So these are the different types of lightning protection systems. The first one is Faraday's cage. In this Faraday's cage, it is based on the electric shield principle. It is mainly based on the electric shield principle. The charge will pass through the conductive cage, thereby not harming the devices into the devices in the cage. That means it will pass the current through the conduction cage, which is placed nearby the lightning effect. The Faraday's cage can be used to protect sensitive electronics from the lightning. That means if any sensitive electronic devices are there, through that to protect that electronic devices, a cage type of material is being used. You can see this cage, and the high amount of current is being passed through this cage, and the current will not flow through the electronic circuit or electrical circuit which is being placed inside the cage. So in this way we can protect the circuit which is being placed inside the cage. Second one is Franklin rods. Here you can see this is nothing but your lightning rod which is being placed on a tall place or a tall building. On a tall building, we will be placing this lightning rod, and whenever a lightning strike occurs from the cloud, the current from the cloud passes through this rod which is being placed in a building, and it will go through the ground, and it will go through the rod which is being placed here, which is being placed. So lightning rods provide a low resistance path. They provide a low resistance path to the ground. That means if at all any building is there, they provide a low resistance path. As we all know, the current always prefers the low resistance path. So the current which is being drawn from the cloud, from the lightning effect, it will directly flow through this rod to the ground. So low resistance path to the ground that can be used to conduct the enormous electrical currents when lightning strike occurs. So the second point is the lightning rod system is an excellent conductor and thus allows the current to flow through the ground without causing any kind of heat damage. That means it is the rod which we are using is a very good conductor, is an excellent conductor. So the whole current flows through the rod only and it will not damage the remaining part of the building. For structures less than 75 feet, that means for these structures or for the buildings less than 75 feet, class 1 material needed to be used, and for normal houses and for small office buildings use these kind of rods. Next one, for structures more than 75 feet such as stacks, transmission towers as well as cell phone towers and antennas, class 2 material must be used. That means for small buildings we will be using class 1 type of material, and for towers more than 75 feet, that is the H towers, A towers, or A towers, different types of transmission towers will be there. Those towers are more than 75 feet. For these type of towers we will be using class 2 material of type of lightning rod in order to protect the devices from the lightning strike. What are the different lightning protection system? Ground terminal, surge protection, different types of conductors as well as air terminal. Here you can see there are different types of conductors, that is primary aluminum conductor, primary copper conductor or secondary aluminum conductor and secondary copper conductor. The lightning protection conductors are designed to handle the short duration, high current flowing of due to the lightning strike. That means in order to bear this lightning strike, the cable size also should be decided. So these are the different sizes. Here you can see the first type is concentric type and the second type is smooth wavy type. And this one is solid type. So here you can see primary as well as secondary, and you will be using the aluminum conductors as well as the copper conductors in order to protect the devices from the lightning strike. Choosing the conductor. Here you have three different criteria, that is solid round, smooth wave as well as concentric. That is solid round. Here you can see this is your solid round type of conductor. In solid round, it is easy to install and can be bent at any place. That means a rod can be bent at any place. And straightening tool may be required. A straightening tool may be required for this, and it is less obvious to see that wider about 25 into 3 mm tape. It is as wide as 25 into 3 mm tape. The second type is smooth wave. That means this is the smooth wavy type. This category, it does not have any memory. It directly is directly used from the roll. It is directly used from the roll. Once bent, stays in the shape. That means once it is bent, the shape remains as it is, and it does not have expansions and contraction problem. That means based on the temperature conditions, the size may expand as well as contract. But in this type of cable, there are no expansions as well as contractions, and it is difficult to make 100% straight. This is one of the drawback. That means once it is bent, it can't be made into straight again. The third type is concentric type. The third type is concentric type, and it has it needs to be uncoiled. That means it needs to be uncoiled, and when bent, it unwinds or frays. That means it can't be bent easily, and not widely used in LP applications. That is lightning protection applications. In lightning protection applications, we don't use this concentric type as it cannot be bent easily. So these are the three different types of conductors which are being used for the lightning protection system. Copper versus aluminum. As I said, the conductors can be made up of copper or aluminum. So which one is better? Either copper or aluminum. Here you can see the features of copper. That is, they are very heavy and they are very expensive and compatible with most building material and can be buried in the underground also. They can be used for overhead lines as well as underground lines, and they are heavy. The weight of the copper wire is more and they are expensive when compared to the aluminum, and they cannot be used in surface atmospheres. The next type is aluminum. Aluminum is very cheap, low in cost, light in weight, and can be used in galvanized surfaces, and it cannot tolerate moisture. It cannot tolerate the moisture as well as the alkaline levels. So the corrosion takes place. So corrosion in marine or as well as seaside environment. Corrosion will occur mainly in the marine as well as seaside environment. So by this we can know that copper is being mostly preferred for underground cables. Copper is mostly preferred for underground cables because the weight is heavy and it is expensive, but it can withstand the atmosphere conditions which when it is buried in the underground. So copper type of material, copper type of cable is mostly preferred in underground cables, and aluminium is mostly preferred in overhead lines or in the ducts. So aluminium is cheap and lightweight. It is cheap and lightweight, so it can be used in overhead lines as well as in ducts, and copper is used in underground cables. Heavy duty applications. There are light duty applications as well as heavy duty applications of different cables. Here you can see lead covered and copper conductors. Lead covered copper conductors and bare copper air terminals. So these are here you are using the stainless steel, and here again it is lead covered. So by using the lead or the stainless steel, the cables are being protected. And here you can see the smoke and stack vent is considered as heavy duty if it is the cross-sectional area of the flue is greater than 500 centimeters square and the height is more than 75 feet. Height is more than 75 feet means mostly for the different types of transmission lines. The sulfur content of the flue could be copper conductors. There are lead covered and they are mostly used for 25 feet. That means if the sulfur content is there, we will use for 25 feet. If the height is more than 75 feet, we will be using this first type. And if ladder of pipes coming down from the towers, the conductors should be bonded with them in order to weigh down. So these are the different types of conductors with stainless steel covering as well as the lead covering for different types of applications based on the height of the building. Next one is ground terminal. How to connect the ground terminal? The ground is a terminal point. Ground is a terminal point for all the lightning protection system. That means you can use different types of lightning protection system. For any kind of LPS, the grounding is compulsory. So it helps to dissipate the energy. It helps us to dissipate the energy. It has mainly three components, that is the bus bar, the ground rod as well as the ground rod clamps. Bus bar, ground rod as well as ground rod clamps. Here you can see the clamps. Here you can see the ground rod. So the clamps as well as the ground rod are being shown in the picture. Ground terminal. In this picture, you can see the connection of the ground terminal. Here you can see the wall. This is nothing but the wall. And the clay, which is this area is being filled with clay. These are the different type of light current that is being flown through this rod. Normally, the ground rods are vertical or horizontal. these rods are nothing but they can be of vertical as well as horizontal depending upon the type of installation. The ground rods go up to 15 to 20 feet. That means this height is around 15 to 20 feet below the ground level. So by providing this, we can protect the different electrical as well as electronic goods as well as buildings from the lightning strikes. Surge protection devices, SPD. This is one of the protection device. Surge protection device is an IEC term. It is an IEC term given to a device intended to limit the transient voltage and divert the surge current. That means in order to flow the voltage as well as in order to divert the surge current, we will be using this surge protection device. What is the purpose? The purpose is to eliminate the potential difference in order to eliminate the potential difference and to protect the structure or building or electrical or electronic devices, and to correct the which is being correctly located and installed for the protection of the building. So these are some of the purposes of SPD, that is surge protection devices, which protects the buildings, electrical or electronic goods, which tries to reduce the potential difference in order to remove the lightning strike, in order to reduce the effect due to the lightning strikes. Surge protection device working principle. SPD contain at least one non-linear component which under specific condition transients between the high as well as low impedance state. A normal operating voltage of SPD is at high impedance state. It is around high impedance state. And what are the limits? It clamps the voltage amplitude to a safer level. It improves the voltage level to a safer level so that the potential difference reduces and the strike may be eliminated. So after the transient is being diverted, the SPD will automatically reset back to the SPD based on these technologies, that is spark gaps, air gaps, gas discharge tube and metal oxide varistors. Based on these different technologies, the SPD works. Change transfer system. This is one of the transfer system where you can see a pinpoint which cannot hold the charge. It will be immediately discharged. This phenomenon is called natural dissipation. That means the current is being naturally dissipated to the ground here. And they are being provided with 80 such pinpoints. Here you can see the different pinpoints. They are being provided with 80 different pinpoints in order to flow the current. Here you can see it can be used as both lightning as protection as well as for the prevention also. So CTS can be used for protection as well as for the prevention also. This is another type, that is dissipation array system, where the conventional design transfer the current to the ground. They do nothing to prevent the lightning. That means they do nothing to prevent the lightning, but whenever the lightning occurs, the current is being flown through them, and it can reduce the damage which may occur. This TAS is advancement of the CTS. That means previously these pins, you can see they are like straight pins are being provided in CTS, but here in DAS the pins are being bent. This is one of the DAS system. Here you can see the cloud where different positive terminals are being there, and when the potential difference increases the dissipated voltage, the lightning may occur. In order to avoid this particular dissipation array is being provided, which acts as a ionizer. That means the positive ions are being collected and being flown through this rod to the ground or the ground level, to the ground level, and this is ground current collector which collects, this is the ground level collector which collects all these positive charges in order to reduce the lightning effect. Here you can see the different DAS system design which is being provided on the top of this tower, which is being provided on the top of this tower. So this can be used as a protection as well as prevention. This can be used for both protection as well as prevention from the lightning strike. The next topic I would like to discuss about the earthing design. Thank you.